My dear students, now we are going to look at higher order mux. Higher order mux design. How do we do this? This we will have a look. So far what you have studied is 2:1 mux, 2 inputs, 1 selection line, 1 output, 1 enable. So this enable is whatever is there. This you can use it for power saving. Power saving. The second use of this enable pin is to get a higher order mux design. So in a higher order mux design, we are going to use the enables. Okay. So this is a 2 power n is to 1 form. This is 2 is to 1 mux. This is I0. This is I1 followed by enable. Right. So now let's look at how to design 8 is to 1 mux using 2 is to 1 muxes. So if you want to do this mux design, see here how many we have, 8 is to 1. How many we have, 2 is to 1. So how many such 2 is to 1s required is 8 by 2. So 4 required. So what exactly that is, I'll take 4 is to 1. Sorry, what exactly is, we need 4, but each is of 2 is to 1 mux. So this is 2 is to 1 mux. Next 2 is to 1 mux. Next 2 is to 1 mux. Next 2 is to 1 mux. Okay. So what we try to do is, for this to choose one out of this, we will use another 2 is to 1 mux. To choose one out of this two, I will choose another set of 2 is to 1 mux. To choose one out of this, I will use another set of mux. So for all these things, what I am trying to do is, here 8 is 2 power n, where n is equals to 3, 2 power 3, n is equals to 3. Number of selection lines are 3 for 8 is to 1 mux. If for 2 power 2 is to 1, 2 power 1, n is equal to 1 selection line. So for every multiplexer, 2 is to 1 multiplexer, I have only S0. So for this two, only S0. So I say S0, I say S0. Here I am not uh, using enables, just enable will be there as it is, no issue. Now from here I am getting an output that is input to the next multiplexer. Here there is an output which is input to the next multiplexer, input to the next multiplexer. So what I try to do is, this is I0, this is I1, next this is I2, this is I3, next I4, then I5, then I6, then I7, right? So this is also 2 is to 1, this is also 2 is to 1, this is also 2 is to 1. In the next stage, I am going to connect for both of them. The next selection line S1, S0 is LSB, S1 is MSB. Okay. So what I try to do is, S is S1 is equals to 0, S1 is equals to 1. So when 0 and 1, based on that we are going to select this 2 is to 1 mux or this 2 is to 1 mux. So there will be an output from here which is connected to the next stage. This is also 2 is to 1 mux. We will be having output Y, and here we are going to have, okay, here we are going to have S2. When S2 is equals to 0, S2 is equals to 0, it will be from this set of boxes. From when S2 is equals to 1, this set of boxes. Okay. So are you getting what exactly the thing that is happening? So in this way, if I connect it like this is nothing but 8 is to 1 mux using 2 is to 1 muxes. Okay. So now you can understand why we are putting S0 first, which is common for everyone. S0, S0. Here it is S1, here is S2. Where S2 is MSB, S0 is LSB. S0 is LSB, S2 is MSB. So now you see here what exactly the output. S0, S1, S2. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. What is your output? Either it may be I0, I1, I2, I3, I4, I5, I6, I7, right? When enable is 1. Of course, by default, I am treating all enables are ones. I am not showing that, but still we can show it. It is not an issue. But if you see here, when S2 is 0, when S2 is 0, what exactly that is happening is when S2 is 0, you will choosing with which you are working from I0 to I3. When S2 is equals to 0, it is choosing to this path. So to this path, what are connected? To this path, I0 to I3 are connected. When S2 is equals to 1, when S2 is equals to 1, which one? This is 0, this is 0, this is 1. Of course, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 inputs. So when S2 is equals to 1, whenever S2 is equals to 1, S2 is equals to 1, it will be choosing 1. So what are connected to 1? The one which are connected to 1 are I4 to I7. So when S2 is 1, okay, one out of this will be chosen. One out of this will be chosen based on what? Based on S0. Once this is chosen, then rest depends on S0 and S1. So what is the value of S0? S0 is equal to 0, S1 is also 0. That means I4 will be the output. For 0, 0, I4 will be the output. S0 is equals to 1, S1 is equals to 1, 1, 1. 1, 1 means from here 1 means I will get from here. From here 1 means S0 1 means where exactly? S0 1 means it is I7. And from this also 1 means, so I7 will be passed. So for S0 1, S2, S1, S0 1, S1 also 1, for S2 is equals to 1, I7. So what I mean to say is, based on the S1, S2, S3 values, corresponding inputs will be selected. I hope you got this, what exactly I would like to express. What I mean to say is, you have to give these inputs to selection lines to S0, S1 and S2. Then you can see that from the functionality of 2:1 multiplexer, 1 out of the 8 will be chosen and will be available as output 5. This is what exactly the case. Now what we can do with this is, with this knowledge, one can build say 64:1 mux using 16:1 mux. How many are required? 64 by 16. So 4 such are required. Okay. Let us suppose if you want to build 16:1 mux using 4:1 muxes. How many required? How many required? Is 16 by 4. I want to get 16 inputs. For one I will use only 4 inputs. So 4 such are required. Okay. To make the inputs. But when you go for the further analysis, You'll come to know do you require anything more. Say for example, if I go for 64:1, so I'll go for 4, 4, then done. How many selection lines? 2 power, this is 6, this is 2. So now what I need to do is to choose one out of the 4. I use one more, I use 4:1 mux. This is 16:1, 16:1, 16:1, 16:1. There are 4 outputs, I'll connect over here. And to choose one out of the 4, I use the MSB lines. Okay. For all of them, I use 4 lines. Select how many? 4 selection lines common. 4 selection lines common. Okay. So 2 more selection lines. MSB selection lines I am going to use here. S0 to S3, S4 and S5 I am going to use here. I'll choose one out of 64. So here it is I0 to I15. Similarly, this is I63. Okay, so on and so forth. One can represent these numbers. This is I16. This is I31. This is I32. Okay, then this is 47. I48. Then I63. So this is why. This is how I can do it. So I need 16:4, 1 multiplexers 4, 4:1 multiplexer to choose 1 out of 4. Similarly, if I take this case, 16:1 mux by 4:1, what I try to do is I'll use the 4 blocks. For what sake? To get my 16:1, 4 blocks. Then to choose 1 out of the 4, I'm going to use one more 4:1. So totally 5:1, totally 4:1 is 5 required. Whereas in case of this, okay, case 4 16:1, 1 4:1. 4 1:1 plus 1 4:1. Totally 5 4:1 multiplexers required. So you can have 4 input lines here, 4 input lines here, 4 input lines here, 4 input lines here. You can combine the same selection lines, 2 selection lines, 2 selection lines, and 2 more selection lines. So it is 2 power 4, totally 4 selection lines, 2 selection lines over here which are common, which is S0 and S1, and S2 and S3 will be here. And to choose one out of the 4, so we will be connecting from here output of this over here, then we are going to get output Y. So this is 4:1, this is 4:1, this is 4:1, this is also 4:1. So in general, what we can do is, in step 1 what we are doing is, we are trying to look for how many inputs are there for our multiplexer and how to build that. We have 16 inputs, but we need 64. So how many? 4 such things can build 64. Similarly, when we want 16 inputs, but we have only 4 inputs, 1 block, so 4 such are required. Then for one multiplexer, you need 2 selection lines, which will be LSB I am using in common. Rest of the selection lines, are this. Rest of the selection lines are this. Okay, are used to choose one out of the possibilities. Now you can draw the table, that is input output relations, and you can validate the design. This is how higher order multiplexers are designed with lower order multiplexers.